All right, so real quick, I mean, why are we in this industry? Well, we know that cannabis has the promise of treating a lot of illnesses. For instance, cancer, MS, ALS, diabetes, just name a few. It's actually composed of 3 different species. Cannabis itself is a genus. And the 3 species, you might be familiar with Cannabis sativa, Cannabis indica, and Cannabis ruderalis, all right, otherwise known as the autoflowering species.
Gary, I know you're
so
but you got to be quiet up
the
here.
cannabinoid and terpenoid profiles vary greatly across these. So I mean, right now there needs to be a lot of research to figure out what these cannabinoids and terpenoids do with one another to our CB1 and CB2 receptors, so we can get a better idea of how to use these for treatment. I don't know if you've all heard of the entourage effect, but it's where you get multiple cannabinoids or terpenoids coming together to form hybrid receptors from CB1 and CB2 receptors on the cells, the effects of which, well, need to be researched. We don't really know. Let's see here. So the majority of the cannabinoids that we're after, and terpenoids, about more than 90%, will exist in the resin glands, otherwise known as trichomes, on the flower clusters that we call colas. Okay, and I should point out that cannabis cultivation, it's not like growing fruits and vegetables. It's more like growing really, really delicate cut flowers. Okay, it grows in very, very dense flowering clusters. These dense flowering clusters, they just get larger and larger over time. And if you want to get the maximum amount of potency, the highest quality product that can be used as a medicine from this plant, then you have to take some rather extreme measures in the state of Florida in order to get it to do that. Because as I mentioned earlier on the panel, cannabis doesn't care if it gets moldy. It'll still produce seed, pass its genetics on for the next season. That's it. It's an annual. It starts in the spring, and then it grows, and then flowers in the fall and winter, and then it dies. That's just what the plant is programmed to do. So what we have to do is we have to coax this maximum amount of potential out. We have to coax the plant to produce a very high yield so we can meet demand for the medication, and also we need to get as much medication per gram of flower that we can. Now, due to the high humidity in Florida, as I'll show you as this talk goes on, doing outdoor growing, which would be great, or greenhouse growing, it's not going to work very well in Florida. You might get lucky. You might be able to grow a crop in the winter if we have a dry winter, and who knows, maybe you'll get a nice yield with some nice product out of it. However, that's not going to be consistent. And when we're talking about medication for people that are sick, we want consistency. We want the product to have a consistent cannabinoid and terpenoid profile, and we also want to know how much we're getting with each harvest, okay? And we want to be able to do this year-round, by the way. All right. So these are the species of cannabis that are available to us. We have the sativa, as I mentioned. The sativa tends to grow much larger. Sativa is the base for industrial hemp. Industrial hemp is a sativa variety that by law must contain no more than 0.3% THC, I believe. This is acclimated to humid environments. It'll do fairly well on its own, but like I said, the plant, all it wants to do is pass its genetics on for the next season. It wants to make seed. That's it. Okay, so just because this plant does well in humid environments doesn't necessarily mean it's going to do well outside in the state of Florida to be used as a medication. Now, Cannabis indica. Indica is another species. It grows fatter leaves. It grows denser colas or flower clusters, and it produces a lot of resin. It's typically the go-to if you're going to do any sort of indoor cultivation because you can get generally really high yields off of it. Ruderalis, that's an interesting variety. It came from Siberia, where the winter months are just inhospitable. So cannabis has to do whatever it can to flower. It'll flower in the summertime, and it doesn't flower based on photoperiod like sativa and indica do. Rather, it flowers just based on the amount of time it's been alive. Okay, and this was just an adaptation for the very harsh climate in Siberia. And then, of course, we have the many, many, many cultivars that are hybrids between these three. Okay, now that's a mistake right there. The hybrids are really fascinating because you can cross sativa and indica strains. You can also cross them with ruderella strains to get that auto-flowering capability. But the key to, or the reason why we do this is so that we can get the best traits from from all three of these different species. And you get what's called hybrid vigor. Okay, so you can actually produce, through hybridization, you can produce plants that are going to be mold resistant, things like that. But what I'm going to show you is that that's not quite enough. It'll work for other environments just fine further north, but for Florida and along the Gulf Coast, it's not going to be work so well. Okay, so here, I just threw this up here because I want to show you that you have all these different cultivars of cannabis with all different potencies of THC, CBD, CBN, there's also CBC, CBG. All of these things have some sort of medicinal value. In fact, CBN and CBC, I believe, or no, CBG and CBN, I think, are the two that are antifungal. So if you have plants that are high in those, then you should end up with a mold-resistant strain. However, it's not going to be quite enough because mold is very pervasive here in Florida. So the parts of the cannabis plant, let's see, do I have a, okay. Anyways, the parts of the cannabis plant, what we have the trichomes, which are after, they sit on the flower cluster, the cola. The cola is made up of hundreds of these calyxes with pistils called stigma. Basically, it's just a tiny flower. The calyx itself is the fruit of the cannabis plant. That's where the seed will grow. Imagine this thing is growing, and a single mold spore gets into this flowering cluster. All right, now the leaves are constantly transpiring water. So that means you're going to have a relative humidity that's slightly higher near the plant itself. So as the cola fills in, the environment becomes more and more humid. The plant's dumping more and more moisture into the surrounding atmosphere. It could give that mold spore the chance to grow and really, form a beachhead on that plant. Once that happens, basically you kind of nullify this whole thing for becoming medicine. Mold begins to grow at around a relative humidity of 70%. All right, it's very easy to get 70% relative humidity, as you well know, in the state of Florida. And so what you want to do in order to draw the moisture out near the cola, you need to keep your humidity relatively low. Because essentially what humidity is, it's a gradient of concentration of water in the air. So if you keep the humidity between 30 and 50%, you're going to be fine. Mold will not take hold, or it'll be very difficult for it to take hold. So that's the target. Now, it's very hard to do that outside or in a greenhouse. And this is what happens as a result of unmitigated humidity control. You get this nice, what's called blight or bud rot. Basically, it just starts to devour your flowers, and it just turns gray to a whitish color. And it'll actually hollow out the cola itself. So what's really fascinating to me is that you can have a cola that looks just fine. And it might go through the hands of your trimmers. If you're a cultivator, your trimmers might trim it up, throw it into a pile, it'll be just fine. It's not until you open it that you realize it's completely infested in mold, and you'll see some of these things will just be completely hollowed out. The only thing that'll be left is this shell of nice, pretty-looking flower on the outside. But you put this into a container and you store it with other flowers that are perfectly fine, it's going to infest everything. All right, and so these things it's a fungus. It produces mycotoxins, and also the spores themselves can become active in the human body. Can you imagine an immunocompromised person trying to inhale the smoke or the vapor from a cannabis plant that's infested with mold, but they're immunocompromised? They're inhaling thousands upon thousands of mold spores that could go into their lungs and just start growing. This is a common thing with a particular mold called Aspergillus. People can actually become infected. They can get lung infections from that. And that can be harmful to deadly, really, when you think about it. Let's see. So here are some things that people might try in the state of Florida to mitigate humidity. All right, so they might try breeding a strain high in CBG and CBC. However, can you get enough CBG and CBC in the plant to really stave off a mold infection? I don't know. I don't think you can. Mold is, like I said, too prevalent in Florida. In fact, you don't really have to have an infestation for you to test too high in mold spores. You just need to have an abundance of mold spores in the atmosphere. You can try just using sativa strains because they grow more sparsely. Again, it's still going to get mold. The plant doesn't care. It just wants to produce seed. You can try a low density of packing for your plants and use more air movement to kind of dry out the buds. But if you already have high moisture content in the air, it's going to have trouble pulling that transpiring water away from the leaves. And also, you're going to reduce your production because you're not going to be packing these things into your operation as dense. So you're going to require more footprint. You can try more forceful air movement, really blast your colas with lots of air. You do that, you risk damaging the plant. You can wind burn a plant. They have fairly delicate leaves. You can try some minimally toxic topical mitigations. For instance, you can use neem oil, you can use garlic, baking soda, vegetable oils, phosphates, soaps, mineral oils, silica. All of these things are going to do one of two things. Okay, they're either going to clog the stomata, which are the little tiny pores at the bottom of the leaves, at the underside of the leaves, that allow water to transpire out and that also bring in carbon dioxide that the plant needs. Or it's just going to burn the flowers themselves. These things, you can spray this stuff all day long on a plant that's in vegetative, but once it starts to flower, once it starts to produce calyxes and stigma, then what you're going to do, you're just going to burn those. It's going to inhibit further flower production. All right, so the only way to truly mitigate mold is just through strict climate control. All right, now here's a good chart to show you why Florida is different from everywhere else. If you look at Florida and you look at Texas, all along the Gulf Coast, you see that we have an average dew point temperature of about 60 to 65, in some cases greater than 65. Okay, this is the annual average. So in the summertime, it actually goes much higher than that. Now, what the dew point actually is, the dew point is an indirect measurement of the moisture content in the air, irrespective of temperature. Okay, relative humidity depends on temperature, all right, but dew point does not. And what the dew point is, it's the temperature at which, when you drop, or the temperature at which, when dropped to the dew point, all the water precipitates out. Okay, so it's also known as wet bulb temperature. And you can measure this directly, or you can measure this indirectly using a hygrometer and a psychrometric chart. So a little bit of, I guess, engineering or meteorology is required to kind of understand this perhaps. But Florida and the Gulf Coast states have the highest absolute humidity, or the highest moisture content in the continental US. Okay, so you're going to be working very hard to remove any moisture that's in the air already. All right, so I have an example. We're going to compare the moisture content from two different states at two different extremes of the nation. We have Florida and Washington. Okay, and Washington State has an average annual dew point temperature of 40 degrees Fahrenheit. Florida has an average annual dew point temperature of 65 degrees Fahrenheit. We're going to look at the moisture content for both of these locations at 80% humidity. Okay, so in order to do this, we have to use this psychrometric chart. Okay, and I'm not going to go through the mechanics of using this chart. However, you may trust me, and I can show you after the talk if you like. When we use the chart to find what the actual moisture content is at 80% relative humidity, we find that the humidity ratio, the amount of water, the mass of water to mass of air, is 0.005 in Washington and 0.012 in Florida. So in Florida, at the same relative humidity of 80%, there's over twice the moisture content in the air. All right, so in other words, you're going to be working twice as hard for humidity mitigation in any circumstance. But this is also why greenhouses and outdoor growing works great further north you go. It works fine in Colorado. In fact, you want it to be a little humid. You want to use evaporative cooling in states like Colorado because it's very, very dry there. And you want to maintain something around at least 30% humidity. Your plants thrive better in it. So I'll just go over outdoor, greenhouse, and indoor real quick. And so of course, we know the benefits of outdoor. You have a very large footprint. Land is relatively cheap. Of course, you have to have land anyways if you're going to put up a structure. So this just, gets rid of the cost of a structure. However, you can only get 2 harvests per year. That would be in the fall and winter. Because cannabis is a short day annual, it requires a long dark period to induce flowering. Also, all of your plants are susceptible to the elements, so we already have high humidity in Florida. We have lots of rain, too. That's going to make matters worse. Plus, we have lots of pathogens that love to exist in our tropical climate, so that's going to be a problem. You're going to have to spray your crop, and people don't like to do that because oftentimes when we spray crops, we're adding some sort of toxicity to the material that's going to be used as a medicine or at least a consumable. So you have no humidity mitigation outside that I'm aware of that actually works. So this right here is kind of out of the question. So then one might be tempted to try a greenhouse, okay? Well, you get the free light, right? You have some sort of limited climate control there. At least you have your plants out of the elements. However, you're still exposed to inconsistent lighting from the sun because you're going to have a lot of cloudy days here in Florida. Also, the best you can do in greenhouse, you can use multi-walled polycarbonate paneling, which has an R value less than 3. Typically in our homes, we put an R value of at least 13 in the walls, and I want to say around 30 in the ceiling. That's what gives us our nice, comfortable climate indoors when we use air conditioning. You can cool a greenhouse with a swamp cooler or using some sort of evaporative cooling. However, you're evaporating water to do this, so you're going to dump more humidity into the environment. Typically, what's coming out of a swamp cooler or evaporative cooler is 85% relative humidity, and that's going to be adding way too much moisture into the air in your greenhouse than you can possibly scrub out with any sort of humidity mitigation or dehumidifier. And of course, you can't cool a greenhouse with AC because your insulation value is much too low. Okay, so then indoor is the way to go. And indoor has a few other added benefits. First of all, you have strict climate control year-round, so you can control even your photo period. You can harvest 5 to 6 times a year. You have to use CO2, basically, if it's a closed system. So you can use CO2 and boost it from 380 parts per million, out like it is outdoors, to 1,500 parts per million. That's going to give you at least a 50% boost in yield. Okay, so now you have consistency in the amount of cannabis flower that you can grow. You also can do multiple varieties in this. You don't have to worry about having some sort of special variety just for outdoors or for high humidity. And you can have consistency in the potency of your product. So all very important things when you think about the availability of medicine for people that need it. And also from a business perspective, when you think about, well, you can kind of predict what your next harvest is going to give you in terms of revenue. So one thing that I put down here that could become possible in the future, you could conceivably construct a transparent panel to make your indoor grow more like a greenhouse where you would have a high R value. Okay? However, doing this could be costly, so we'll see what happens in the future as far as products are concerned to allow this to become a possibility. So maybe you could still have your cake and eat it too. But so my conclusions, well, cannabis does grow very well outdoors, okay, but as I keep mentioning, all it wants to do is drop seed. It doesn't care that you want to use it for medicine. So it'll still get quite moldy and rendering it useless or at least toxic for medical applications. The need for indoor growing will be unique to Florida and regions along the Gulf Coast. So if you want to do this in greenhouses or outdoors, you should probably move to a different state. Let's see, and then the product quality and consistency will be hampered by pathogens and mold and high humidity ratio if you try to do this outdoors or in a greenhouse. So I keep reiterating that we're trying to create medicine for people. We don't want our flower to be populated with mold spores. We don't want it to be populated with mycotoxins. We don't want people to get fungal infections. Public safety is a concern here. And as such, we should really just focus all of our attention on indoor growing. And finally, I just had to throw this in at my very last point, that the vertical licensing system is kind of a public health risk, because if they're only awarding a limited number of licenses, then the tendency is to go for a large footprint. And in order to do that, you have to go for some sort of outdoor greenhouse type of thing, because, well, in reality, the indoor grow style is a bit cost prohibitive on the large scale. So if you had more licenses, you could have more boutique growing, and you can also have more varieties available for patients and for research, so we can figure out exactly what these cannabinoids do. And with that, I'll go ahead and stop it here and open the floor for questions. Thank you. All right.
Yes, hello, Mr. Landerville. Thank you for taking some time with us. Ryan Hurley. And my question is about a stat that you put up in your slides where you recommended a 30 to 50% relative humidity for excellent cannabis growth. For many, many years, I've heard the number 60%, but you're saying even lower than that is better.
Yeah. 60% would work fine with a low moisture content. Okay, but see, 60% here in Florida, much higher moisture content than 60% relative humidity elsewhere. So.
Okay, yes, I understand that. May I ask you one more quick question? In regards to CO2 addition to your crop, how many parts per million in the air do you recommend?
1,500.
Thank you very much.
No worries.
Thank you for your time, Aaron.
Hey.
Can you answer a question a little bit about UVC lighting and how that might help within moderate amounts with the plant?
Yeah, so typically UVC lighting is used to scrub out air and air conditioners. You just have to be careful that you don't go to wavelengths lower than about 200 nanometers, because then you'll start producing ozone, and that can be toxic to the plant. So typically what people do is stay around 230 nanometers when you're choosing a UVC spectrum. And yeah, that'll help eliminate a lot of spores in the environment. So you can scrub air using that. Still, can you scrub all of it? No.
And there is a very fine line in that it can be toxic to you as well, right?
Yeah. Anybody else? All right. Thank you one more right here.
Hi, my name's Samuel Bowles. I got a quick question for you.
Sure.
To start my own grow indoors with a humidifier, is that very costly to?
Okay, so dehumidification on the small scale, you can use a dehumidifier. Typically what you do, though, is you would just relegate this to your HVAC. So you would install an AC unit that would be about 20%, no more than 20% overloaded for the particular system you're designing. That should provide plenty of humidity mitigation. If you need more, you can buy fairly inexpensive dehumidification to supplement it. So, yeah, no worries. All right, thank you very much.